Welcome to This Explainer. Today, we're jumping right into the hidden and honestly fascinating business mechanics that actually bring blueprints to life. We're going to be focusing on the essential math that turns lines on a page into physical reality. That's right, we are going to figure out how to calculate materials and labor costs.
I mean, just look at this skyline. It is so easy to be completely awed by the sheer size of urban construction. But before any of these massive structures can even touch the sky, someone sitting at a desk has to calculate exactly how much every single piece of it costs, from the thousands of tons of concrete right down to the absolute last screw. Literally nothing gets built without a budget. So that begs the question, how much does a building actually cost? It sounds like such a simple question, right? But for a construction estimator, this is the ultimate daily puzzle. Every single project is completely unique, and getting this answer wrong, well, that can mean the difference between a thriving, profitable business and absolute financial ruin. Okay, let's put a face to this with a practical case study. Meet John. John has been tasked with pricing out a project, specifically laying the foundation for a structure we're just going to call Building ABC. We're going to shadow John step by step today to see exactly how this complex estimation is actually done. So here is our roadmap for solving this puzzle. We'll start with the costing foundation, then quantify physical materials, move into offsite production costs, build the labor team, and wrap up by calculating total labor costs. We're basically taking this massive task and breaking it down into logical, bite-sized chapters. All right, Section 1, the costing foundation. Physical substances versus temporary goods. John kicks off his whole process with something called a quantity takeoff. Basically, he meticulously examines the construction drawings and specifications to identify every single physical substance required. Back in the day, this was all done by hand with rulers and highlighters. But today, software tools like AutoCAD make scanning these blueprints way faster and, thankfully, far less prone to human error. Now, there's a really crucial distinction estimators have to make about what they're actually buying. Materials are the permanent physical substances that literally become part of the structure. Think concrete, structural steel, or timber. Consumables, on the other hand, are the non-durable goods used up quickly on the site, things like packaging, office supplies, or cleaning products. Both obviously cost money, but they hit the project budget very differently. Moving on to Section 2, quantifying physical materials, sourcing supplier prices. Okay, let's see how this builds into real numbers. John inputs his required quantities into his estimation software, which syncs up with current supplier prices. So 80 kilograms of concrete mix at $20 a kilo, that equals $1,600 right there. Add in the waterproof plastic sheets and the structural steel, and John lands at a total base material cost of $3,913.30. And that's just to get the foundation materials on the books.
Next up, Section 3, Off-Site Production Costs, Accounting for External Manufacturing.
While John is focused on the foundation today, later on he's going to need to order off-site elements, like a house roof deck. The raw manufacturing cost for that might be $56,399.69, but an estimator can never, ever forget the logistics. You have to factor in the delivery charge, in this specific case, $215, to find the true total cost. Trust me, a forgotten delivery fee on a massive project will eat up your profit margins incredibly fast. All right, Section 4, building the labor team. Who is doing the work? On any given site, you've got three distinct roles. The contractor is the one who actually enters into the agreement with the client and delegates the work. The employees are the paid workers directly under that contractor. And then subcontractors are the specialists, like plumbers or roofers, hired out by the contractor for highly specific tasks. Estimators have to know exactly who is doing what, because every single one of these roles is subject to strict minimum wage regulations and industry awards, like the Building and Construction General On-Site Award. So, let's apply this to our case study for Building ABC's foundation. John checks his organization's policy, and based on the size of this specific job, he needs a crew of 8. That breaks down neatly into 1 supervisor to oversee the operation and 7 construction workers to actually execute it. Which brings us to Section 5, calculating total labor costs, formulas, on-costs, and insurance. Now, to calculate labor, there is a very strict chronological logic to follow. You definitely don't just guess a flat fee.
First, you calculate the absolute base hours required to do the physical tasks. Then, and honestly, this is a pretty surprising fact for anyone outside the industry, estimators intentionally plan for downtime. They add a percentage just to account for unavoidable unproductive time. And finally, they layer on all the mandatory employer costs and insurances.
Let's take a look at John's software breakdown here. The physical tasks, installing footings, pouring concrete, knocking holes for utilities, waterproofing, they all add up to 98 base hours of work. But when we apply that 10% downtime allowance, the total jumps up to 107.8 hours. Because John's crew is working standard 8-hour shifts, this means laying the foundation is actually going to span across 14 working days.
So the absolutely crucial point here is that John isn't just paying a simple hourly wage. Sure, the supervisor makes $32.60 an hour and the workers make $15.40. But John's company also has to pay mandatory on-costs. We're talking things like superannuation and employee benefits, which cost $63.70 a day for the supervisor and $45.60 a day for each worker. Plus, every single person on that site requires a daily workers' compensation insurance payment of $24.40, to protect them in case of an injury. When you multiply those hourly rates by the 107.8 hours and then multiply the daily on-costs and insurance by the 14 days for all 8 workers, well, here is the big reveal. The labor alone just to lay this foundation is $23,228.52. It is frankly incredible how fast those individual daily minimums snowball into a massive figure. Okay, now we bring it all together to find the final unit cost. This is the true cost per meter to lay this mat foundation. We take our material cost of $3,913, add that massive labor cost of $23,228, and finally add in physical resources, say $1,000 to hire an excavator and some cutting saws for the week. We take that grand total of just over $28,000 and divide it by the foundation's total depth, which is 4.5 meters.
And there it is, the final resolution of our case study, $6,255.63 per meter. That is the exact number John will confidently input into his final tender to bid for the job, knowing for a fact that every single worker, material, and minute of downtime is fully and accurately accounted for. Which really brings us right back to where we started. Every towering high-rise, every sprawling residential block, every hospital and school you see, they all exist only because an estimator meticulously balanced these exact kinds of spreadsheet equations. These calculations literally build our cities from the ground up.
It really leaves you with a staggering sense of perspective, doesn't it? I mean, if tracking the downtime, the concrete, and the insurance for just a single 4.5-meter foundation requires this much detailed calculation, what on earth does the master spreadsheet for a 50-story skyscraper look like? Thanks for joining me on this explainer. I hope it completely changes how you look at the buildings around you.